Okay, so let's continue from where we left off with the compiler. Basically, what we had to do next was to add more tokens to, like, token types to our parser, because right now the Elixir doesn't find the identifiers, also doesn't find, I think, the columns. So what we have to do is to just add more tokens, and we'll see from there. We'll try to go iteratively to the test. So first things first, we have to add the column here. So let's say that we do column. Just keep the order, and for this function we have to also add the string to be able to display it. And let's go to the next token function, and let's add here somewhere, doesn't really matter, I guess, the case for the column. So let's do it, I guess, after this one. So if we find a column, then we just create the token. So now if we recompile this thing, we should be able to see that we get columns, but we still don't have variables. So let's change that. So let's do here like case. No, I meant first we need to add the ident. It's for the identifiers. And next, sure, fair enough, we have to print the identifier. And then let's go to this thing. And basically here, when we say literal to token, when we create the token from the literal, in this function we need to check that if it's equal to class, then it's a class. If it's equal to inherits, then it's inherits. And in the other case, instead of illegal, let's create the identifier basically. So now if we recompile this thing, we should be able to see that it creates identifiers for X and Y. So that's right. And it also does class name for cell type, which is nice, and for int. So let's see the next test basically. Well, I meant like this. So for the next one, we see that we finally get to something more interesting. We have two characters here. So we need to first read this one, and then we have to pick the parser and see the next character. So let's see how we are gonna do that. Oh yeah, first, I mean, obviously let's add these things, the character. I think let's call it assign, this one, and I mean this one is just assign, and the other one should be just int literal, maybe int literal. Okay, so now if we find assign, okay, we have to just bring the word assign, and if we find just an int literal, yeah, let's maybe like this, it's good enough. So Yeah. Oh yeah, and another thing I think we can do is, instead of using um, like all of these functions, what if we just use include C type? If we use character type, right? We would have to fix some stuff. So is space with the replacement here. Okay, then here we have is lower letter, which should be is lower, basically. Then for is word char, we need is basically alphanumeric, which is all the letters and all the numbers. And we have that. And this one is for class name, so it should be is upper. And this one should be is alphanumeric or underscore. Right, so that would be all the replacements, and we get rid of those hyperfunctions. Let me see. So yeah, basically, um, if we try it, it still works. That was the goal. Well, I mean, I would also just do something like this, elixir01, just to rewrite the references, because like this looks right. Yeah, you'd have to double check it and stuff, but it's the best way to do it, I guess. I mean, I'll have to do it on my own, but yeah. So we added here the assign and the literal. So the next thing would be to actually tokenize them. So let's see. Let's continue. Let's continue here. So else if we find this kind of arrow, if we find the less than, I guess, we are gonna have to see. So basically, let's say char next, we have to pick, and this looks at the next character, right? So now we have also the next character, and in the case that next is this thing, then we have to read, and I think, yeah, we have to read twice, because we want first of all to skip this one, and we would move on the minus, and then read again just to move after the minus, right? So right now the read position, or I mean the position itself, is on character, and the read position is on the dash. If we read once, the position moves on the dash, and the read position moves on the next character after the dash. And if we read once more, we move the position on the next character after the dash. So that's the plan. And here we can just return a sign. And on the else case, let's do illegal for now. Here should come like it's either less than or less than equal, stuff like that. Okay, so that should probably take care of of the assign. Well, we had an assign here, so it was class name, assign, and illegal because we don't have yet the way to parse numbers. So let's go ahead and implement that. So here we have parsing the lowercase starting stuff, uppercase, and we should have here else if we find a digit, then we need a slice like this, right? Just take that, and then while is digit, we need to just now increase the slice length and read the next character. Move next. So yeah, then we have to convert the slice to a string and just return the int. And yeah, basically we'll keep the value of the int literal token as a string. We don't convert it yet to let's say numbers directly. We keep it as a string. So now if we recompile this thing, see we get the 0 inside of int literal. Okay, let's check now the next one. This has methods, so the only thing I guess would be the parentheses that I see that are new. And is that all? I think so. I think, yeah, only the parentheses. The other stuff is pretty much taken into account for. So we have an illegal here after the class name int. Let's see what's that. Is it the comma? I think so. I think, yeah, it's the comma. So we have to add commas and the parentheses. So let's see. Left parent, right parentheses. I mean, to keep the order should be like this. And the last one should be a comma. Let me sort them. Yeah, it was fine. So after the column we have a comma, case comma. Then here we have L parentheses and right parentheses. So now we also look at those. So yeah, let's go ahead and do. I mean, pretty easy. Did everything for us. Okay, let's check again. I mean, yeah, probably, but it gets really tedious after some point to, just do it manually. I was thinking just to be able to compare easier. But yeah, like what about the fifth test, right? Like this would be like really big. Although yeah, I see that for the next one, actually have false, and we also have strings. I mean, the easy strings, yeah, it's pretty much easy to do them, I think. But having strings with special characters, that's what's a bit more difficult. So yeah. Well, I mean, I would say that, to be fair, this one looks right. I don't see any illegal tokens, and I guess that's a good sign. Right. Well, one thing we can do is grep for illegal. And since we don't have any, I might say that we can do the same just to make sure on this one, and we get some illegal tokens. So here, see, it found quotations around ABC. So yeah, I guess for the fourth one, fifth test, let's add the boolean literal. So that's something I think somehow explained here. The letters true, false. It's a type. Well, I mean, yeah, obviously it's a type, but I was curious to see if we have. Yeah, actually we have, see, true and false for the expressions, but I wanted to see if there are anything specified about it. Oh yeah, it looked weird, but well, how about just adding every operator first? And yeah, but I mean, it's also fun to do it in the order of the test: bool, literal. And now let's test my knowledge on string literal, on alphabetic order, I wanted to say. Yeah. So we have bool literal, case bool literal. I mean, see, this is what I find nice for Copilot. It's that this stuff, it's really easy to copy paste because it's the same as what, another 10. So it really saves you time on those things. But okay, whatever. So let's continue with the booleans. So when we are gonna read the lowercase b, it will go into this one. And yeah, it will read the entire word and then go to literal to token. And what it does here is it checks for class, it checks for inherits. How about checking for true and false? So the question, like my question is, do we want to have true and false as tokens, or as a single token with the value? Uh, I think let's keep a single token with the value. Probably it makes sense. Not sure yet, but like the options that we have are having two boolean token types. One would be boolean true, one would be boolean false, and split them into those two options. And the other option that we choose right now is to keep a single token type and put inside of the literal true or false, which I think, I mean, it's the same thing, doesn't matter, but yeah. So that should take care of booleans. Okay, now for the next one. The next one is for string literals. So let's go ahead. If we find a quote, I think a double quote, we have to wait. Let's create a string slice first. Then we need a while loop. So while I think we can say something like LCH is not equal to this thing, but first we need to do a read. So let's read char. Let's read one character, and then we need to keep going. We need to read until we find this thing. So let's increase the slice length. So now on the last position, and here character will be on a double quote after we exit from here. So we might need to do another read, I think, just to move to the next character. After that we need to create the literal string and just return the string. Now obviously this won't work on complicated stuff, so let's see. I guess we also need, wait, let's do it like this. First we read the character and then we put the slice as the, like, we don't want to keep the quotes, we want to keep only the inner stuff, so that's the reason. So it's a string literal with the value ABC. Now yeah, of course it won't work, we have to do something more complicated than this to read escaped characters. Like, we are gonna create a function for it. So yeah, basically a small function that just creates this literal. So yeah, then let's see what's inside of the sixth thing. So we have some arithmetic operations. So yeah, we just need to add all these token types. So like the plus, star, division, let's see. So now we have to do these things, also this one. So I really want to keep the, so we have plus, I put it like minus, plus, minus, multiply, divide, and that one should be tilde, or it's negate or something, but let's sort this, and we have divide, case divide, return divide, then we had the minus, I think, comes first, multiply and plus, so all of them after L parenthesis. So yeah, we put all of them here, and after that at the end comes tilde. Yeah, it really sucks that we have to create also this function, but it's just for printing purposes, so whatever. Yeah, so the next thing should come, I guess we can put them after the comma, why not? So if we find the plus symbol, we have to do this thing, but here we return a plus. Right, if we find a plus, then there's no other thing that can happen, so it's fine. Okay, if we find a minus, then we have to do the minus, and again there's no other thing that can happen after a minus. There's no arrows, so we just have the minus. Okay, after that we can have a star, and star is the same thing, nothing special. Then we have slash for divide, and last thing would be the tilde thing. Okay, so yeah, basically we added all of them, so let's do a make, and let's see the arithmetic stuff. So basically we have the class name, the brace, the identifier, colon, this thing, unassign, then the int literal 1 plus 2 multiply, then inside of parentheses we have 3 plus 4, then a parenthesis, then the divide, and then we have left parenthesis. Yeah, looks good. So that test also decent, works. 0.7, let's say. Okay, so for relational operators, I think this is the only new one. Oh, this one too. So yeah, as I said in here, if we find this thing and then a minus, if we find the less than and the minus, it's an assign. But then if next is equal to equal, then we have to say that it's, oh, I mean it's less than. So let's go here where it's the else. I think, well, first let's less. Should we do like LP and LTE? Why not? I mean less than and less than EQ. Let's make people upset about the naming. Okay, so these come after LBase, actually, like somewhere around here. Less than and less than equal. Okay, so going back to the sign and stuff, this one should be less than equal because it's a less than symbol and an equal sign. And I think in the other case, anything else we can have here, we should just put a less than. Right, like anything else comes after the less than symbol. Like if it's a letter, if it's a space, anything that comes after it is just the less than operator. So now if we no, somewhere I missed something. So it's on line 274. Well, it means that oh my god. Okay, let's I don't see the diff. Anyway, let's try again. Yeah, it's so strange because this thing works fine. Yeah, somewhere I missed like one parenthesis, I think. Probably is somewhere inside of this. Yeah. Oh yeah, it should be. Oops, like here, it's an else if. Now, okay, so this is the example, and well, I mean, we should have less than equal at some point and less than. So after the 2 is one less. Oh, and we also have a not. Which it takes as an identifier, but it's I think not. Wait, is not something real? Oh yeah, it is. I mean, makes sense. I was expecting that the exclamation mark would be the not, I guess. So other than that, I think all the stuff is good. Oh, it's also equal. Yeah, I forgot about equal. So which one do you think comes first? I was right. So I have equal and we also have not. So, well, I mean, it's negate, but I'll call it not. Right. So we had what equal and not. So here is not. Okay, that's good. And okay, not should come in here. If we find the word not, then we just create a not token. And for equal, yeah, for equal it will be the same thing as for arrow, because we are gonna have the option to, let me place it here, the option to have the, uh, the case thing with arrows. So that's one thing. If we redo make, here we see equal between 1 and false. Well, let me, between 1 and false, and the not before one of the twos. So here, which looks okay. The eighth one is a sign, which I think we already did. 08. Do we have anything strange? I don't see anything strange in the test. Like we did all the tokens. So I mean, that works. That's nice. Is void. So for this one, there's a new keyword, I guess. Is void and new. So let's go ahead and also add those. So is void first should be, I think, like somewhere around there. Yeah, and new should be here. So we have is void and new. After the literal is void and the new should be here. Okay, so the good thing is that both of these can be done with string compare. Yeah, also new. So well, I wanted to make, so basically this is the test case. So we have a not, then is void, new, and then class name A. Everything seems to work. Okay, the next test would be the dispatch. So the @ symbol and the dot. And I think that's everything for dispatch. Self, I mean, it's an identifier, so it's fine. Dot is just a dot, and the @ symbol is just @. So those are the only things we need to add. So let's do @. Oh, okay. And we also have dot. So let's do case @ return @ and for dot, let's do it here. So for the 10th test case, I mean, we have quite a lot. We also see an illegal there after class name A. Oh, we didn't use them. Yeah. Of course we got illegal. So let's do the dot and the @ just like this. So the dot and the @ symbol. So let's see now what happens if we try to look at this stuff. I mean, the classic, I don't see any legal, so it should be fine, I guess. Well, yeah, probably it's fine. Let's think that it's fine. Oh, the if we finally got the ifs, which, I mean, it's just and it's so annoying to keep them in order, but something we need to do for the sake of our OCD. So it's 4 things for ifs. It's the if itself, then the then, and then else and phi. So let's go ahead and do it. So we have if, we have I mean, I'll just phi, then else, and you know what, just sort them. Okay, let's go ahead and do them. So after the dot comes the else, then here should be the fee. I think after ident should come if, alphabetical order, and where should be the then? Well, oh, it's at the end. Wow, poor thing. So the easy thing, as usual with keywords, is that they come here in the literal section. So if is if, then is then, else is else, and fee is fee. Okay, perfect. I mean, you still have to make sure that what Copilot says is, you never know. So the 11 one, and let's see. So go into this mode, and we have the fee at the end, 1 plus x, else another x, the then 5 less than equal. Yeah, the if looks good. I mean, obviously for tokenization the tests could be even simpler, like only this line, and just test it like a unit test, like a really small test. Right, we don't need a program that works, basically. Well, I mean, it doesn't even work, to be fair. It's just that's a full program. It's more like this test was made for the AST parsing. But yeah, I mean that's what it was made for. But you know, we reuse things. Okay, the next test would be 12 for a while loop. So this one is similar. We just add while, loop, and pool. It's nothing new. Let's use the while, pool, or I mean loop, and pool. So let's whatever. Let's sort them. Loop and pool. Okay, I remember them. So after LTE, here should come loop. Pool should be, I think, after the plus. Yeah, after the plus, and while should be the last one. Okay. So I guess it's the same thing as with the ifs. We just compare them to the strings and pretty much everything. Okay, so let's make, and let's see this one. So well, we actually have the loop, some stuff, and then pool, also the while. So it looks good. I mean, these tests are a bit easier because you don't have new symbols or new stuff. Well, for let, we have just let and in. I think that's everything. Let's put here let in. I think that like this. Let in comes after illegal, and let was where? After less than. Okay, before loop. So here we should have in, and here before loop we should have let. Okay, so anyway, let's do 13. And yeah, I guess we should see nothing because we didn't add yet the checks. Okay, so we have to add here let and in. Perfect. So now looking at 13, we see this construction here in and the x ident. And if we search for let, we should find something like let x, then some stuff. So yeah, this one also looks good. Okay, let's go for the next one, for the case. So case, yeah, now it becomes again more interesting with this thing, but let's do case of and ESAC first. Okay, so the classic case, ESAC and off. Yeah. Oh, that would have been a small disaster. Okay, so case, ESAC and off. I mean, I didn't remember them, but now case is after bool, literal. ESAC should be after equal, obviously, and off should be after not. Okay, perfect. Well, let's also add, I have no idea how it's called, but let's do like arrow, I guess. So arrow is first, perfect. Case arrow. Okay, so first of all, let's do the easy ones, which come here. We have the case, off and ESAC. Okay. And now let's go to where we check equal here. And basically we have to copy this kind of structure. So we get the next, right, with equal, already lost it. So we get the next, and if the next character is this thing, then we need to read twice, again the same thing as we did for a sign, and otherwise we have to read only once and return unequal. And yeah, we it's the same logic. We read once because the next character wasn't greater than, it was like a space or a number, something different. Okay, so I think if we test case, we should see something like did I do something wrong here? Did I not compile? Probably. Yeah, so now if we take a look, at least on the last one, we see that like ident O, then object, then arrow, then string literal, semicolon, ASAC, so everything looks good. Have multiple arrows. So I think that's good. Let's see the next one. 15 is a block. So a block is just more squarely braces, so everything should work for this one. And I mean, it looks like it does. So let's do 16, which is the special strings. Yeah. Then for 17 we have something like humongous. Then we have error strings, comment. Do we have 20? Invalid character. I mean, this one will probably work. Yeah. Well, something else that I was thinking, like, how can we maybe do that, was to add inside of the token, let's say, to add also its position, like row and column. Maybe that would be something interesting. Well, the Lexer should also keep the line and the column, besides just the position. So yeah, and here when we skip white space, if we find a new line, then we increase the line number. So that would be the idea. Just to think ahead for the errors. Because I mean, for this one we see illegal, right? But after we do the lexing and we get the list of tokens, we might, well, it's actually that if we have any legal tokens, we should actually we don't stop the lexing once we find an illegal token. We should do something like illegal can be a bit different then. So, for example, if we look at 20 but at the reference, it's gonna be like this kind of error message. Invalid character. Like now, yeah, could be that we put the error message inside of the literal, but that would be a bit strange. And the other option would be to have inside of the token itself. So like this is where maybe Rust would have been better, because all of the, but then token type would be really annoying, because arrow should have literal, a sign should have literal, and so on. I don't think we need position for all of them. I think position is needed just for the error messages. Well, the other maybe another option would be to have here, instead of token, to be able to return like two types. Let's say one would be token and the other one would be error token or something. Yeah, no. I mean, probably it's easier to just put the error inside of the literal, but that's lame. Basically, I would put the position, which we already have, and maybe if it's an error, we have the error type or something. I mean, kind of makes sense. So yeah, let's try and think. So let's say feature basic tokens. We have just the basic tokens. I should have maybe formatted, but it's fine. So here inside of token, I would also maybe add. I wanted to see Lexer first. Where is the Lexer? It's unsigned in position. Struct token. Okay, so maybe adding position and then having a separate function that converts a position into line and column in the printing stage, because yeah, we don't really care about doing extra stuff just to keep line and column, because they are not always needed, right? Like I think it would be more efficient to convert the position into line and column when we need it. So something like this, and maybe an enum error type. Like this would be maybe what we need inside of token. And inside of the literal we can put extra stuff like the invalid character, for example. But yeah, maybe this is how we can do this. And like based on this type, we know that we have to look here or not. And yeah, I mean, that's the only downside is that we made the structure a bit larger. And only because we can have errors. Maybe the other option would be to have like struct result. But even then, if we have a structure for result, we still have to keep a token and the error. So it's not like we can do better in terms of memory. So I'm not sure how to do that efficiently, but yeah, we can have this, the error type. So let's do enum. Error type would be no error, and the first error would be what? Invalid character. Invalid character. So yeah, basically we don't even need to change these, because maybe adding the position, but I don't know if we care about the position for tokens. So in illegal, basically we just need to set the error type and also the position and maybe the thing. So where is illegal? So here, for example, we could easily do a slice, right? Slice. We could say slice dot length plus 1. Then we can create a char pointer literal, take it and put it here. Then let's say pause. Well, we should read afterwards. So let's do something else. Let's do struct token. Say illegal. And let's read at the end. Position is position, and that's it. So we return the illegal token. Here we can just say length is 1. So maybe something like this. Right now if we try to rerun make and then rerun this one, it would say illegal and this, right? So that's good enough for the example. But I think we can do a function like this one from here. So it should be error type to string. So it should be just nothing, and here should be invalid character, right, like this part. And in here we can do an if talk dot type is equal to illegal, then we can do something, and on the else case we can do something else, something like this. And here in illegal we can say, I don't know, something like it's yeah, so this should say invalid character hash, which is close. I mean, it's the same thing, but we need to say the file, the line number, the fact that it's a lexical error. Let's copy this. I mean, that's easy to do. And now, yeah, let's do the line number, because maybe that's interesting to how to do it, right? So let's say we have a void function that is something like pose to LC. So you have a child pointer buffer. Wait, I mean, I didn't want to autocomplete everything. I wanted to just explain like, okay, we're gonna get the buffer, the position, like it's an index, and two pointers, one to the line number and one pointer to the column number. And then we initialize them both with one, whatever, doesn't really matter. And then we have to iterate over the buffer. And basically, if we encounter a new line, we increase the line number and we reset the column to 1. And when we do anything else, we just increase the line number, or I mean the column number. So yeah, that's how we can do it. So basically, here let's have unsigned ints for line and column. Let's get those, and it should be what, line, then percentage d colon, percentage d, it's a comma, yeah. So then here we have line and column. If we remake this and build it, let's do cat just to see it. So we get the line numbers in this error. The last thing would be to show the file name, but we don't get it here. So I mean, probably in the future the Lexer should return a list of tokens, and we do this printing outside of the Lexer, if that makes sense. And in the outside, like where this thing is used, inside of main, whatever, here we should see somewhere like run Lexer. Here we have the file name. It's called input. So yeah, we actually have the file name. So yeah, I mean the only thing would be if you read a program from standard input. If we enable that, then there's no file name. What if you have multiple files? Because I think Cool works with multiple files. You can concatenate multiple files, but I think it's something like you read one file, you tokenize it. Well, I mean, you read all the files, you tokenize each one individually, and then you combine them. Something like that. Not sure. I think you combine them after you tokenize. Because you cannot have like a string starting in one file and ending in another file. Like you cannot have splits, I think. I mean, I'll have to check, but yeah. So basically, today we were able to go up until the special characters in strings. Right, like it parses some stuff, but we'll need to fix, the parsing of the special strings, because some things like this thing is not is illegal. This thing works, but you actually have to, like, this has to convert into a new line, so it's not right, it should be on the next line, right? It should be like the literal character new line. This one should be a tab, basically. This one should be a slash, like we should see it as a single slash. This one should be, I think, a Z, because if you have a slash and anything after it, it is just the character in this language in particular. So yeah, those are the special strings. And then this one is just a test for using comments, I think, or something. This has more errors in the string. So yeah, 19 was errors in the comments. So yeah, basically next time let's do the string, like the real string stuff, the real string work in here, and also the comments. So I mean, yeah, well, we also have single line comments, but like the real ones, those with that require a stack basically. So yeah, next time we'll do the strings and the comments, and we'll have the full tokenizer. I think that's the entire tokenizer of the Lexer, and after that we can start on building the AST of the language. So that should be more interesting. And after the AST, the classics of semantic analysis, trying to get the errors. And I think like for compiler we can try to do like an intermediate language to apply some optimizations and then straight into assembly. And yeah, I mean, in this like in the book of the language they say that it uses MIPS, or I mean whatever they use, like in their homework, whoever created this thing said that you should use MIPS, but I mean probably because it's easier, so we'll try with that. But yeah, for now the tokenizer is almost done, and see you next time.